said, there's no point in, well, the reason that we are working on linear systems is so that we can solve application problems, okay? There are a lot of things that come up that require us to use a linear system of equations, okay? If you're looking at something in your immediate future, it's on the ACT, all right, having to write these application problems. But you'll see in the problems that we have, there are a lot of situations that can be modeled this way. So if you are given an application problem, the first thing you need to do is identify important information. Okay? What are they asking you to find? What information is relevant to the problem? What information is not relevant to the problem? So you may want to circle some things, underline, highlight, whatever you need to do. Okay? Define your variables. Before you can do anything else, you have to tell me X represents this, Y represents this. Okay? And you have to be specific. You can't just say Y equals girls. Y equals girls what? No. Y equals the number of girls. Okay, it has to be a numeric value. All right, we're solving for numbers, so make sure your variable makes sense in terms of numbers. Okay. After you define your variables, we're going to write the equations based on the variables that you chose, which means the way that Nick sets it up may be different than the way that Courtney sets it up, but that does not mean that they are both wrong. Okay, they might choose their variables to be different. Okay, solve based on whichever method either you feel comfortable with or works with the problem. And then be sure to actually answer the question. A lot of times you are finding multiple variables, but they're only asking you for one specific number. So make sure you answer what they are asking you to find, and you label based on what you define your variables to be in the beginning. Okay? So I want you to take a moment, and I want you to read through example number 1. Actually made up this problem. Okay, I went to Vallis website, looked up their prices, which are quite expensive for a weekend, right? So here we go. Let's talk about important information. What's important in here? 60 is important. There are 60 guests. What else is important? Okay. The amount that they took in.
Price of an adventure pass.
Okay, price of an adventure pass. What else? Okay, general admission is $18.95. Okay. What are we asking? What are they asking us to find? Okay, how many general admission passes? How many general admission passes? Okay. So, turn to your neighbor and talk about what the two variables would be. Ready, go. All right, pod 1, what would our two variables be? You're so chatty.
Okay, I said G and A.
Well, what do they mean?
G is the general admission, A is the adventure pass.
Yes, Nick? So we're talking about number of tickets, okay? I want your variables to be a numeric description, okay? The number of general admission tickets and the number of adventure passes, okay? I want you to be specific, okay? Now, if you got really excited and you chose different letters for your variables, that's fine, okay? But I like that we're getting out of our X and Y comfort zone. Thank you for doing that, pod 1. Okay, now we need to set up our equations, okay? So we have two variables. You need to at least have how many equations? 2, in order to be able to solve, okay? So one equation is going to be based on our 60 guests, okay? What needs to add together to be 60?
G.
Maverick.
G plus S.
Okay, the number of tickets for general admission plus the number of adventure passes needs to equal our 60 guests. Okay. Then we have this money. They collected $1,262. Do you have some other information about money? Do you think those need to be grouped together? Probably, okay? So, total, they made $1,262. Each general admission ticket costs $18.95. Plus, each adventure pass costs $23.95. Okay? Now, I put the dollar signs up here to emphasize that this all deals with money, but you don't need to put the dollar signs. Okay? That's not going to be relevant to you actually solving the problem. Okay? Now, you're probably going to want your calculator because 18.95 and 23.95 aren't going to be nice numbers to work with. How many of you vote that we should use elimination? How many of you vote substitution? Let's try this again. How many of you would vote elimination? How many substitution? Oh, about half and half. Okay? Does it matter? It does not. Okay? I think that this is a nice one for substitution. Well, it's really a nice one for either way. But since we haven't done a lot of substitution, let's do substitution. Okay, we've done a lot of elimination lately. So I would write that 60 minus A equals G. And then we could substitute that in. So we would have 18.95 times our new G plus 23.95A equals 1262. Okay, so help me out. What is 18.95 times 60? Okay. When we combine negative 18.95A plus 23.95A, that would give us what?
5.
5. Ooh, 5A. And if we subtract 1,137 over to the 1262,
125.
oh, that is nice. We don't even need a calculator for that. 125 divided by 5? 25. Okay, let's take a step back. What are they asking us to find? They want just a general admission, okay? We found the adventure pass, so we need to go back up to our general admission is 60 minus A. How many general admission passes did we sell? 35. Okay? Now, you are not going to write G equals 35 and circle it. Answer the question. Valet sold 35 general admission tickets. Give me the numeric value in context to the problem. Okay, now, a lot of you got really excited and were like, setting up your equations, working ahead without me. I'm glad that you feel comfortable doing that. Okay, I'm going to throw you for a loop, though. We're not going to example 2 next. Okay, before we move to example 3, are there any questions about this Vallis problem? Yes.
If you solve for, if you substituted A and then solved for G right away, could you have just kept that?
Yes. Okay. Yes, and that's good. And I did this for a reason, so that somebody could ask that question. Okay, I solved for G and plugged it in using substitution, and then I got my A value. Well, what if I would have said A equals 60 minus G and substituted that in? We would have gotten a numeric G value, and we wouldn't have even had to go back and find A, okay? That could have saved me a step, okay? So you can think ahead a little bit. If you're using substitution or elimination, eliminate the variable that you don't want to find. Find if they're asking for one. Now, sometimes they'll ask for both, but if they're only asking for one, we can think ahead a little bit. Thank you for pointing that out. Okay. All right, take a moment and read through example 3. All right. Please turn to your neighbor and discuss how many and what the variables are. Turn to your neighbor. Okay, how many unknowns are there? There are 3 unknowns, okay? They are asking us to find how many, well, there's actually like not a quite, well, it's written on your sheet, right? Write the system of linear equations to model the data in the article to the right. Solve the system to find how many athletes finish in each place, okay? Let's talk about some relevant information. Is 20 important? Yeah, we have 20 individual places, okay? For combined 68 points, okay? It says first, second, and third place finishes earn 5, 3, and 1 points respectively. PLSHS had a strong second place showing with as many second place finishers as first and third combined. Is that important? So I'm going to go ahead and circle that right there. Okay, I've circled and underlined a couple things, right? Okay, so Nick said 3 variables. Eli, what are the 3 things we're trying to find?
The number of first, second, and third place finishers.
Okay, what do you want to call those variables? Okay. F, number of first place finishers. Remember, you can choose whatever variables you want to. These are the ones Eli wants to use. What did you say? FS? And T. Okay, I'm just trying to save some room up here. All right, so if we have 3 unknowns, how many equations should we try to write? 3. You have to have 3 in order to be able to solve for those. All right? So let's take our first piece of information, 20. We have 20 individual event placers. 20 individual event placers. Okay. What would need to add to 20? Okay. These represent finishers. 20 finishers. So first place finishers plus second place finishers plus third place finishers should equal 20 total finishers. Okay. All right. 68 combined points. We need to look for information based on points. What do we know about point values from the article?
First is 5.
Okay. First is 5. Second is 3. And third gets 1 point for a total of 68. Okay. Second place has finishers, okay, as many second place finishers as first and third place finishers combined. Second place is as many as first and third combined. So how would we write that?
F plus T equals S.
Okay, F plus T should equal X. First and third combined should be as many as second place. Okay, here are our 3 equations. Now, would you say that they look like the equations that you had last night as far as how they're set up? This third one, not really, right? We're used to seeing all the variables on one side, do you agree? Okay, now, this is the correct setup for the problem, but it would be my advice to you to rewrite that third problem. By the way, did you see the date of the article? You thought it was real, didn't you? Maybe I can just see into the future. Okay, so it'd be my advice to you to write that third equation as F minus S plus T equals 0. That way, it's easier to use elimination to eliminate a variable twice. Okay? Which variable would you like to eliminate? S sounds like a good choice, right? We can take the first and third equations to get 2F plus 2T equals 20. What other 2 equations could we choose? First and second? So what would we have to multiply the first one by? -3. Okay. So -3F minus 3S minus 3T equals -60. Combine that with the third to get 2F minus 2T equals 8. Does that look good to you? Well, that worked out really nice. Right? What can we do with those 2 equations? We can use elimination on those 2. right? We can take this equation right here to get 4F equals 28. 4F equals 7. We have 7 first place finishers. Where should we go with that one? We're going to go back to one of these, right? I would probably come back to this one right here. Okay, 2F plus 2T equals 20. 2 times 7 is 14, so we get 2T equals 6. Or T equals 3. We have 3 third place finishers. Okay. Then we can come back even all the way up to here. F plus T equals S. So how many second place finishers do we have? We have 10. Yeah.
Since you started out with F plus T equals S, couldn't you just start out by substituting the S in?
Like
Sure.
S into the other two?
Yeah.
Yeah, that would work. That would work. Okay, so to answer the problem, we have 7 first place finishers. Second place, and 3 third place. All right, how do you feel so far? Feeling good? Read example 2, and I'm going to give you 2 minutes to, as a group, read the problem, dissect the information, define variables, and only, I said only, set up the problem. All right, so let's talk about our variables. Pod 2. What are our 3 unknowns? What? And what do those represent? So the number of TV ads, the number of radio ads, and the number of newspaper ads. Okay, how many of you use TR and N? Okay, look at you guys. Okay, cool. So now, pod 6, 5, you're pod 5. Give me one equation. T plus R plus N equals what? There are 60 total ads, and so together they need to add up to be 60. Awesome. Pod 4, give me a second one.
T equals R plus N.
T equals R plus N. The number of TV ads equal the radio newspaper combined. Or do you agree with that? Okay, excellent. Pod 1, what else do we have?
4,200 equals 1,000 T plus 200 R plus 500 N.
Plus 500 what? N? Sorry, I got a little...
50,000. We need to see another zero.
That's right. All right, so the total amount of money they need to take in should equal the money times TV ads plus the money times radio ads plus the money times newspaper ads. Okay, we need to be consistent with our labels within each equation. So then, like we did earlier, I would probably rewrite the second one so then you can use elimination if that is the method of your choice. Guess what? You just set up one of your homework problems. Some of you are ignoring everything I have to say and you are solving it right now. Okay? That's a homework problem. Good job. Okay?